This is the EdExcel GCSE 91 Maths Paper 2 from the November 2020 series, and this paper is a calculator paper from the higher tier. Question number 1. For part A, we have to write 84 as a product of its prime factors. We begin with the 84. Two numbers which multiply to give 84. We've got 2 and 42. 2 is a prime number, 42 isn't. So the 42 we can further split up as 2 multiplied by 21. 2 is a prime number, 21 isn't. So the 21 we can further split up as 3 multiplied by 7. And so therefore 84 is the same as 2 times 2 times 3 times 7. In other words, we've got 2 to the power of 2, that represents 2 times 2, multiplied by 3, multiplied by 7. Then for part B, we have to find the lowest common multiple of 60 and 84. Well, 60 we can write as the product of its prime factors. Two numbers which multiply to give 60, we've got 2 and 30. 2 is a prime number, 30 isn't. The 30 we can further split up as 3 times by 10. 3 is a prime number, 10 isn't, so the 10 we can further split up as 2 times by 5, and 2 and 5 are prime numbers. And so therefore 60 is equal to 2 times 2 times 3 times 5. So when we come to find the lowest common multiple, of 60 and 84, well, we've got this 2, which is common to both. We also have this 3, which is common to both. And we've also got this 2 here, which is common to both. So we've got the 2, here the 2, and the 3. And then we've also got this 5. And we've also got this 7. And we need to multiply all those together. 2 times 2 is 4 times 3 is 12, times 5 is 60, times 7 is 420. So the lowest common multiple is 420. Question number 2, we've got a set of numbers here, 1 to 10. A, we've got even numbers, and B, we've got factors of 10. And for part A, we have to complete the Venn diagram for this information. Well, what are even numbers? We've got the 2, 4, 6, 8, and the 10. The factors of 10, we've got 2, 5, 1, and 10. So what goes into both? We've got the 2, and we've also got the 10. Now the 2 and the 10 have been used up from our even numbers. What's left over? We've got the 4, 6, and the 8. And then for B, we've got the 5 and the 1. Now what numbers haven't been used? We've got the 3, the 7, and the 9, which have not been used. Now for part B of the question, a number is chosen at random from the universal set. We have to find the probability that this number is in the set A and B. Now, out of the 10 numbers, we've got How many of them are in A and B? Well, that's 2 of them. And so it turns out here, we get 1/5 as the required probability. Question number 3. Carlo puts tins into small boxes and into large boxes. He puts 6 tins into each small box. He puts 20 tins into each large box. Carlo puts a total of 3,000 tins into the boxes so that the number of tins in small boxes to the number of tins in large boxes is in the ratio 2:3. Carlo says that less than 30% of the boxes filled with tins are large boxes. Is Carlo correct? You must show your working. Well, first of all, with the ratio, we can find out the total number of parts we have. 2 plus 3 is 5. And so you can see we've got 5 parts. Now, if we've got 3,000 tins, we can divide that by 5 to get 600. You can see we've got 600 per part. And so what we can do is find out the number of tins in small boxes and large boxes. So the number of tins in small boxes, we've got 2 multiplied by 600, which is 1,200, and the number of tins in large boxes would have 3 multiplied by 600, which is 1,800. Now, to find out how many small boxes we have, well, we know that we've got 6 tins in each small box, so the number of small boxes is equal to 1,200 divided by 6, which is equal to 200, and the number of large boxes we've got 1,800 divided by 20, which is equal to 90. And so if we were to find out the total number of boxes, the total number of boxes, we've got 200 plus 90, which is 290. We've got 290 boxes. Now let's see what percentage of boxes are filled with tins are large. So therefore the percentage we've got is 90 divided by 290 multiplied by 100. So if I work this out, 90 divided by 290 times 100, we get 31.03 etc. %. And clearly that doesn't equal 30%. Carlo says it's less than 30, we've got something more than 30, and therefore Carlo is incorrect. Question number 4, we have to complete the table of values for y equals 5 minus x cubed. So first thing we'll do is go to the table function, we key in 5 minus x cubed, we will start at minus 2, we will finish at 2, here we have 13, here we have 5, here we have 4, and here we have -3. And now we have to draw that graph between -2 and 2. So we end up with this graph here. Question number 5. We've got to work out the value of x. We've got a right angle triangle here. The hypotenuse is 178. The opposite is x. We've got this angle, which is 34. And so sine 34 equals x divided by 178. And so x equals 178 times by the sine of 34. So working out what that is, we get 99.5. So we have 99.5. Question number 6, we've got a which is equal to 3, 4 and b which is equal to 5 minus 2. We have to find the vector 2a minus 3b. So we've got 2 lots of 3, 4 minus 3 lots of 5 minus 2. So 2 times by 3 is 6, 2 times 4 is 8, and then we subtract. Well, 3 times 5 is 15, 3 times negative 2 is negative 6. So if I work this out, 6 minus 15, that's minus 9. 8 minus 6, that's 8 plus 6, which is 14. And so our vector is minus 9, 14. Question number 7. The diagram shows a right angle triangle and a quarter circle. And the right angle triangle ABC has an angle, ABC being 90 degrees. We've got this quarter circle which has a center at C and a radius CB. We have to work out the area of the quarter circle to 3 significant figures. Well, if I consider my right angle triangle, I can first of all find out what CB is. That will equal 9 squared subtract 6 squared square rooted, and that's through Pythagoras. So if I work out what this is, I end up with 3 times by the square root of 5. And so the side here is 3 root 5, and also the side here is 3 root 5. So for me to work out the area, I've got a quarter circle. So the area is equal to pi multiplied by my radius squared. So I've got 3 root 5 squared divided by 4 because I've got a quarter circle. So if I work this out, 3 root 5 squared divided by 4, it turns out we have 45 pi divided by 4. And as a decimal, it turns out we get 35.34, etc. meters squared. So we have 35.4 meters squared given to 3 significant figures. Question number 8. Tarek buys a laptop. He gets a discount of 5% off the normal price. Tarek pays £551 for the laptop. We have to work out for part A the normal price of the laptop. Well, if x is the normal price, that means I've got 0.95x, that's including the discount, so that's a 5% discount. This is equal to 551. So if I work out what x is, it turns out we get 580. So the normal price of the laptop is £580. Next, Joanne invests £6,000 in a savings account. The savings account pay compound interest at a rate of 2.4% for the first year and 1.7% for each extra year. For part B, we have to work out the value of John's investment at the end of 3 years. So the value after 3 years, well, we've got 6,000, and then in the first year we've got 2.4%, so that as a multiplier is 1.024, and then we've got 1.7% for each extra year. So here we have 1.017, and then we square this because we've got another 2 years. So if I work out what this is, we get £6,354 and 67 pence. Of course, we need to give our values to 2 decimal places. So we've got £6,354 and 67 pence. Question number 9. Aisha recorded the height in centimetres of some girls. She used her results to work out the information in this table. We've got the least height, lower quartile, interquartile range, median, and the range. Aisha drew this box plot for the information in the table. The box plot is not fully correct. We have to write down 2 things Aisha should do to make the box plot fully correct. Well, straight away I can see that the median is 162. She's plotted the median at 161. So what could she do to make her box plot fully correct? Well, we could plot the median at 162 instead of 161. Now let's look at the upper quartile. They've plotted 172. Is that the case? Well, the interquartile range is equal to the upper quartile subtract the lower quartile. Interquartile range is 17. So we've got 17 equals upper quartile, we don't know what that is yet, subtract the lower quartile, which is 154. And so therefore the upper quartile is equal to 171. And so they've plotted the interquartile range at 172, so we could plot the upper quartile at 171 centimeters, not 172 centimeters. Question number 10. We have to simplify 1 over m squared to the power of 0 for part A. Well, anything to the power of 0 is quite simply 1. For part B, we have to simplify 8 lots of x minus 4 divided by x minus 4 squared. Well, here, the x minus 4 cancels once with the x minus 4 squared on the bottom. And so what we will be left with is 8 over x minus 4. For part C, we have to simplify 3n to the power of 4 w squared all to the power of 3. Well, what this is the same as is 3 to the power of 3 multiplied by n to the 4 to the power of 3 multiplied by w squared to the power of 3. We have 27 n to the power of 12 w to the power of 6 as our simplified expression. Question number 11. Jack is in a restaurant. There are 5 starters, 8 main courses and some desserts on the menu. Jack is going to choose 1 starter, 1 main course and 1 dessert. He says there are 240 ways that he can choose his starter, his main course and his dessert. Could Jack be correct? Show how you get your answer. Well, if we let D equal the number of desserts, then we've got 5 starters multiplied by 8 mains multiplied by D desserts, and it turns out we get 240. And so therefore the number of desserts we have is 240 divided by 40, which is 6. So there's 6 desserts. And so could Jack be correct? Well, he could be correct when we have 6 desserts. Question number 12. The graph gives information about the volume v litres of petrol in the tank of Jim's car after it has travelled a distance of d kilometres. For part A, we have to find the gradient of this graph. Well, to do this, we need to find the change in y, which is 27, divided by the change in x, which is 300, and so therefore the gradient is equal to negative, because the line's going down. We have negative 27 over 300. And if we work out what this is, we get minus 0.09. So we have minus 0.09. And now for part B of the question, we have to interpret what the graph represents. Well, we've got volume and we've got distance. If I add these units on, we've got volume, which is in litres, and then we've got the distance, which is in kilometres. So what could this represent? Well, it would represent the volume of petrol used each kilometre. Question number 13. Here is a triangle ABC. We have to work out the length of AB, give your answer to 1 decimal place. So here we've got 2 angles already in a triangle. We can find out the missing angle, recognizing that angles in a triangle add up to 180. The missing angle is 120. So this angle here is 120. Now we've got a side, an angle opposite it. We are finding AB and we've been given the angle opposite it, and so we would have to use the sine rule. And if we were to use the sine rule, we have AB divided by the sine of 34, which is equal to 23.8 divided by the sine of 120. And so if we rearrange for AB, we have 23.8 multiplied by sine 34 divided by the sine of 120, and so if we work all this out, we get 15.367, etc. And so to one decimal place, we have 15.4 centimeters as the length of AB. Question number 14. Here are two squares A and B, and the length of each side of square B is 4 centimeters greater than the length of each side of square A. The area of square B is 70 centimeters squared greater than the area of square A. We have to find the area of square B. Give your answer correct to 3 significant figures. You must show all your working. First of all, if we let the side length of A equal x, what we're saying by that is here I have x, and also here I have x. Then if the side length of B is 4 centimeters greater than the side length of A, then here I have x plus 4, and here I have x plus 4. And we know that the area of B is 70 centimeters squared greater than the area of square A. So what we can do at this point is set up an equation. We've got the area of square B, that's x plus 4 squared, and this is equal to x squared plus 70. And the reason we add 70 is because of the statement that we were told in the question. And so what we need to do is find out what x is, and from that we can find out what the area of B is. X plus 4 all squared, that's the same as x squared plus 8x plus 16, and this is equal to x squared plus 70. Now happily for us, the x squareds cancel on both sides, leaving us with 8x equals 70 subtract 16, which is 54, and so therefore x is equal to 54 divided by 8, which is 6.75. And so therefore the side length of B is equal to 6.75 plus 4, which is 10.75. And what we need to do in this question is find the area of B to 3 significant figures. So the area of B is equal to 10.75 squared. So if I add 4 and then square, we get 115.5625 centimeters squared. And giving our answer correct to 3 significant figures, we end up with 116. Question number 15. We have to describe fully the single transformation that maps triangle A onto triangle B. Well, clearly the shape's getting bigger, and what we need to do is match up the corresponding sides. So if we do that, let's match up this with this, and then we match up this with this, and then we match up this with this, and it turns out then that our centre is at 1, 1. And if we take a look at our scale factor, we are going from a side length of 2 to a side length of 3, and so our scale factor will be 3 over 2, or 1.5 in other words. And so we've got an enlargement with scale factor. Now here the scale factor will be negative 3 over 2. And the reason it's negative 3 over 2 is because we are going in the opposite direction, and the center of enlargement is 1, 1. Question number 16. Here are the first 5 terms of a quadratic sequence: 10, 21, 38, 61 and 90, and we have to find an expression in terms of n for the nth term of this sequence. So the first thing we will do is we will find the difference between each term. So if we find the difference between each term, well, here we have 11. The difference between 21 and 38 is 17. The difference between 38 and 61 is 23. And the difference between 61 and 90 is 29. And what we do at this point is we find the difference between each of these, which is positive 6. And so to find the coefficient of n squared, what we need to do is take this 6 and then divide it by 2, which gets us 3. And so therefore, the coefficient of n squared is 3. Now, at this point, we write out the n squared terms. We have 1, 4, 9, 16, and 25. And then we write out the 3 n squared terms. 1 times 3 is 3, 4 times 3 is 12, 9 times 3 is 27, 16 times 3 is 48, 25 times 3 is 75. And then at this point, we write out the sequence. So the sequence we have 10, 21, 38, 61, and 90. And then we find the difference between the sequence and the 3n squared. So we will do sequence subtract 3n squared. 10 take away 3 is 7, 21 take away 12 is 9, 38 take away 27 is 11, 61 take away 48 is 13, 90 take away 75 is 15. And at this point, we find the difference between each of these. So the difference here is positive 2. And at this point we do the inverse of plus 2, which is subtract 2. So that gets us 5. And so therefore, for the quadratic sequence, we have 3n squared. And then we add on the 2n, and then we add on the 5. So the nth term of the sequence is 3n squared plus 2n plus 5. Question number 17. We have to write down the coordinates of the turning point on the graph of y equals x plus 12 all squared minus 7. Well, the x coordinate will be the opposite of plus 12, which is minus 12, and then we have the y coordinate being minus 7. Question number 18. The diagram represents a solid cone. The curved surface area of the cone is pi rl, and the cone has a base diameter of 20 centimeters and a slant height of 25 centimeters. A circle is drawn around the surface of the cone at a slant height of 10 centimeters above the base. The curved surface of the cone above the circle is painted grey. We have to work out the area of the curved surface of the cone that is not painted grey. We have to give our answer as a multiple of pi. You must show all of your working. Well, the first thing we will do is find out the curved surface area of the cone. We've got L, which is 25, the radius is half of the 20, which is 10, and pi is just a constant. The total curved surface area of the cone then, that will equal pi multiplied by 10 multiplied by 25. So here we get 250 pi. Now what we need to do is somehow find the surface area of the grey bit. Now for us to do that, we need the diameter of the small circle. How could we find that out? Well, what we can do to begin with is find out what this over here is, and that will equal 25 take away 10, which is equal to 15. So the slant height of the grey bit is 15 centimeters. And what we can do is use similar shapes to find out the diameter of the base of the cone. That will equal, well, let's just write this down. The diameter of the smaller cone then, we've got 20 multiplied by the scale factor, which is 15 over 25. And if I work out what this is, I've got 20 divided by 25 times 15, which will equal 12. So here I get 12. Let's add this to the diagram. From here to here, we've got 12 centimeters. And so therefore, what we can now do is find out the area of the smaller cone. The area of the grey cone, that will equal, well, we've got pi multiplied by the radius, which is 6, half of the 12, multiplied by the height, the slant height of 15. So here we end up with 90 pi. 6 times 15 is 90. So that's the area of the grey cone. And at this point, to find out the area which is not painted, that will equal 250 pi subtract 90 pi, which is 160 pi centimeters squared. Question number 19. A hot air balloon is descending The height of the balloon n minutes after it starts to descend is hn meters. The height of the balloon n plus 1 minutes after it starts to descend is hn plus 1 meters, given by hn plus 1 equals k times hn plus 20, where k is a constant. The balloon starts to descend from a height of 1200 meters at 9:15, and at 9:16 the height of the balloon is 1040 meters, and we have to work out the height of the balloon at 9:18. Well, let's think about the information we know already. We know that initially at 9:15 we are at a height of 1200 meters, so that means h0, this is the initial height, is 1200, and at 9:16, that's h1, the height is 1040. And so if we substitute this into here, where we have h1 equals k times by h0 plus 20, then we've got 1040 equals k multiplied by 1200 plus 20. So we've got 1040. Well, let's just find out what k is. We've got 1020 equals 1200 k, and if we attempt to find out what k is equal to 1020 divided by 1200, which is 0.85. And so therefore we've got hn plus 1 equals 0.85 h0 plus 20. And what we need to do over here is find out the time at 9:17 and then 9:18. So at 9:17 h2 is equal to 0.85 h1 plus 20. So we have 0.85 times by h1, which is 1040, plus 20. And if I work this out, we get 904. And then at 9:18, which is what we're after, h3 is equal to 0.85 h2 plus 20. So we've got 0.85 times by 904 plus 20. So 0.85 times this plus 20 is 788.4. So we have 788.4 meters. Question number 20. There are only red sweets and yellow sweets in a bag. There are n red sweets in the bag. There are 8 yellow sweets in the bag. Sajid is going to take at random a sweet from the bag and eat it. He says the probability that the sweet will be red is 7/8. We have to show why the probability cannot be 7/8. Well, we've got n red sweets out of a total of n plus 8. And what fraction we see here is the probability that the sweet will be red. We've got n out of n plus 8, which are red. And we're saying that this is equal to 7/10. Now let's see what happens when we solve for n. Well, we have n multiplied by 10 equals 7 multiplied by n plus 8. 10n is then equal to 7n plus 56. 3n is equal to 56. Well, n is not going to be a whole number. So n is equal to 56 over 3. So the n equals 56 over 3 is not a whole number, so we can't conclude for definite that the probability is 7/10. Now for the next part of the question, after Sajid has taken a sweet from the first bag and eaten it, he's going to take at random a second sweet from the bag, and we're told this time that the probability that both sweets he will take will be red is 3/5. We have to work out the total number of sweets which are red in the bag, showing our working. Well, what we have over here is we've got n sweets out of n plus 8, and then we multiply this by, well, if I eat a sweet, that means we've got n plus 7 left over. And how many red will I have? Well, that'll be n minus 1. And what this will equal is 3/5. And so what we need to do is find out what n is. Well, on the top, we have n multiplied by n minus 1. And on the bottom, we have n plus 8 multiplied by n plus 7. And this is equal to 3/5. So I've got 5 multiplied by n minus 1 equals 3 multiplied by n plus 8 multiplied by n plus 7. 5n squared minus 5 equals 3 multiplied by n squared plus 15n plus 56. And if we expand out, well, the left hand side stays the same. But on the right hand side, we've got 3n squared plus 45n, and 3 times 56 is 168. And if we now attempt to rearrange, we have 2n squared, and then we have minus 25n, or rather minus 50n, minus 168 equals 0, and then we have n squared minus 25n minus 84 equals 0, and attempting to factorize, we have n plus 3 multiplied by n minus 28 equals 0, and so n equals minus 3 or 28, and as n must be a whole number, we can conclude that we have n equals 28 only. So how many red sweets do we have? 28. Question number 24. The graph of the curve y equals f of x is drawn on the grid. And for part A, we have to sketch the graph of y equals f of minus x. Well, what transformation do we have here? Well, we have a reflection in the y-axis. So we take our graph here and then we reflect it in the y-axis. And if I do that, what we'll end up with is something looking like this. So here we've got the graph of y equals f of minus x. And now for the next part of the question, the curve C with equation y equals 5 plus 2x minus x squared is transformed by a translation to give the curve S such that the point 1, 6 is mapped to the point 4, 6 on S. We have to find an equation for S. Now, can you see, to go from the 1 to the 4, what we are doing to the x's is we are adding 3, but the y's are not changing. So what type of translation do we have? Well, we have a translation by vector minus 3, 0. We're moving 3 to the right, which is why we've got the minus. And so we will replace the x with x minus 3. So if we replace x with x minus 3, we've got our curve S having equation y equals 5 plus 2 multiplied by x minus 3 minus x minus 3 squared. This is the equation for S. Question 22. We've got C, which is a circle with the centre at the origin. The tangent to C passes through the points minus 20, 0 and 0, 10. And what we have to do is work out an equation of C. You must show all of your working. Well, let's draw a diagram. Here we've got the circle and we've got the points minus 20, 0 and 0, 10. And what we also know is we've got a tangent to the circle which passes through these points. What we need to do is find out the equation of the circle C. What we'll do to begin with is find out the gradient of the tangent to the curve. So the gradient of the tangent, that's equal to, well, we've got here 10 take away 0 divided by 0 take negative 20, which is equal to 1/2. And so what we can conclude from here then, the gradient of the radius is minus 2. Now, what we'll do is we'll show the equation of the radius over here. So we'll call this R and we'll call this T. What we'll do is find out where the radius meets the tangent. Well, first of all, the equation of the tangent, that will equal, well, if the gradient's 1/2 and it passes through the point 0, 10, the equation of the tangent will be y equals 1/2 x plus 10. So this is the equation of the tangent, and the equation of the radius, that will be y equals minus 2x. And what we'll do is we'll set these two equal to each other to find out where they intersect. So we've got 1/2 x plus 10 equals minus 2x. And so 2x plus a half is 5/2. So we've got 5/2x equals minus 10. And therefore x is equal to, well, I've got minus 20 divided by 5, which is minus 4. And y then is equal to minus 2 times minus 4, which is 8. So I found the coordinates of where the radius meets the tangent. It's at minus 4, 8. And so what I can do now is use Pythagoras to find the radius. So the length of the radius, because it passes through the origin, we have 4 squared plus 8 squared square rooted. And if I work out what this is, 16 plus 64 is 80. So the radius is equal to the square root of 80. And therefore, C has equation x squared plus y squared equals 80, which is root 80 squared. So this is the equation of the circle.